Atoms lose or gain electrons to achieve complete valence shell. When it holds the maximum number of electrons, that makes them stable. For majority of elements, that means getting 8 electrons on the most outer shell. Fluorine is 1 electron short from the having full octet, 8 electrons on the valence shell. It will steal 1 electron to become an ion with a charge of -1. Phosphorus is 3 electrons short of having a full octet. It will steal 3 electrons to add them to its valence shell and become an ion with a charge of -3. Magnesium is 6 electrons short from the full octet, but stealing 6 electrons requires too much energy, so magnesium is much more likely to lose 2 valence electrons and become an ion with a charge of +2. Underneath there is a full octet. Potassium is 7 electrons short from the full octet. If it loses 1 electron, it will have a full octet underneath, and it will become an ion with a charge of +1. Atoms gain or lose electrons to become more stable as ions. For majority of the elements, the end goal is to have a full octet, 8 electrons on the most outer shell. But for small atoms such as lithium, beryllium, boron, stability can be achieved through getting down to having only first electron shell and having 2 electrons on it. The first shell is complete when it holds 2 electrons, making those ions more stable. Considering that having full valence shell is the way to become stable, the most stable and consequently unreactive elements are the ones that already have that. Noble gases are called so for their unreactive nature, which comes from the fact that they already have the full octet on valence shell, or in case of the helium, a full duo.